Imagine waking up one morning to find your compass pointing in the completely wrong direction. Your maps and navigation apps are useless because the magnetic North Pole has decided to pick up and move. Sounds like a crazy sci-fi premise, right? But get this, that scenario isn't just possible, it's happened repeatedly throughout Earth's 4.5 billion year history. The magnetic poles we rely on have flip-flopped positions many times, and scientists think we may be overdue for another reversal. So, stick around, because today we're uncovering the mysteries of Earth's flipping poles. What causes these magnetic reversals? How do we know they've happened before? And what kind of bizarre compass chaos could we be in for if the poles flip again soon? Let's dive into one of the most mind-bending phenomena on our restless, ever-changing planet. Before we get into the flipping and reversals, let's make sure we're all on the same page about what the magnetic poles are. When you think of the North and South poles, you probably picture those fixed geographic locations at the top and bottom of our planet. The ones where Santa and his elves supposedly live. Well, the magnetic poles are an entirely different beast. These are the two wandering locations where the magnetic field lines point vertically up from the North Pole and down into the South Pole. They're kind of like magnetic force field projectors at opposite ends of the Earth. Unlike their geographic counterparts, which are fixed locations, the magnetic poles are constantly on the move across the Arctic and Antarctic regions. Their locations today are already significantly shifted from where they were a few decades ago. It's like they have a severe case of wanderlust. So, while your geographic north will always point towards the top of the globe, magnetic north is a traveling target. That's why compass needles don't quite line up with true north, and why ships and planes need to adjust their navigation from time to time. The magnetic poles have a mind of their own. Now that we know what the magnetic poles are, let's talk about their slippery history of reversals. According to the geological record locked into ancient rocks and sediments, the magnetic poles have flip-flopped their positions many times over millions of years. This humble little rock contains magnetic minerals that tell the tale of a pole reversal 780,000 years ago. The magnetic particles are oriented in the opposite direction of today's magnetic field lines, like tiny fossil compasses pointing the wrong way. Researchers have uncovered evidence of hundreds of these reversals over the last 160 million years or so. The magnetic field has a restless nature, taking around 10,000 to 20,000 years to fully flip from one polarity to the other and back again. But could you imagine if one of these reversals happened while you were trying to navigate using a compass? Your directions would be scrambled like an omelette. It would be like using a GPS app that suddenly starts recalculating and sending you in circles every few minutes. 1 minute you're headed north and the next you've done a 180 towards the complete opposite direction. Talk about getting lost. Fortunately, these reversals tend to happen gradually over hundreds or thousands of years. But that doesn't make them any less disruptive to our navigation systems that rely on magnetic north. During a reversal, compasses would essentially be rendered useless as the field flips between polarities. What causes these reversals? What's behind these magnetic reversals that have happened hundreds of times throughout our planet's history? The root cause lies deep within the Earth itself, in the churning, superheated ocean of liquid iron that makes up the outer core. It's like that terrible sci-fi movie, The Core, from 2003, but infinitely cooler and based in reality. Beneath the solid mantle and crust we're walking on, the outer core is a roiling 1,800-mile-wide sea of molten iron alloys, heated to around 5,400 degrees Celsius or 9,800 degrees Fahrenheit. That's about as hot as the surface of the sun. As this blazing metallic fluid flows and churns, it creates electric currents that generate the magnetic field extending from the Earth's core out into space. Think of it like a self-sustaining dynamo or bicycle generator, but on an astronomical scale. The convection currents in the liquid outer core are constantly twisting, shearing, and realigning the magnetic field lines in complex ways. While the field is predominantly dipolar, with two poles, it's far from a perfect bar magnet. There are lots of smaller eddies and perturbations mixed in. Over thousands of years, this roiling dynamo can reinforce localized magnetic instabilities until they start to dominate over the main dipole field. As the reversed flux patches gain more strength, they can trigger a complete reversal of the magnetic polarity in a process taking 2,000 to 12,000 years to complete. While the cause seems simple enough, moving iron alloys in the core, the details are mind-bendingly complex. Those wildly chaotic motions are what allow the magnetic poles to flip their orientation from time to time in such a dramatic way. Potential impacts of a reversal. While these pole reversals sound dramatic, it's important to note that they don't happen overnight. The entire process plays out over hundreds to thousands of years as the magnetic field gradually weakens, flips polarity, and then rebuilds strength in the opposite orientation. However, during that extended transition period, there could be some temporary side effects we'd have to deal with. As the overall field strength drops, more high-energy cosmic radiation could make it through to the Earth's surface. Just imagine having to worry about cosmic rays frying the electronics in your phone every time you try to send a text message or play Wordle. You'd need to keep your devices shielded or risk getting hit with crippling data corruption. Fortunately, the Earth's atmosphere and magnetic field still provide decent shielding even when the field is in transition. But an extended period of weakened magnetic protection could potentially wreak havoc on satellites, spacecraft, and even ground-based electronics like power grids. But before you go renovating your basement into a fallout shelter, it's worth keeping some perspective. Life on Earth has been around for several billion years and survived many, many pole reversals in that time. The last one was about 780,000 years ago, and life carried on just fine. While navigation might get a bit screwy and we'd have to take precautions against cosmic rays, a reversal wouldn't be the doomsday scenario the media sometimes portrays. The magnetic field has flipped polarity hundreds of times before, and it will inevitably flip again in the future as part of the normal geological process. So, try not to lose too much sleep over an impending pole reversal. Just maybe avoid planning any long sailing voyages using a compass for the next few thousand years. How scientists study reversals. So how do researchers piece together the evidence and timing of these ancient pole flips? The key lies in examining magnetic minerals locked into ancient rocks and sediments laid down over millions of years. When molten lava cools and solidifies into volcanic rocks, or when sediments become compacted into layers of sedimentary rock, any magnetic minerals present have their polarity aligned with the Earth's magnetic field at that time. It's like a fossil record of the planet's magnetic orientation. By analyzing the magnetic particles in rock samples, geologists and paleomagnetists can recreate where the north and south magnetic poles were located when the rock formed. Combine enough data points, and you can map out the paths of past pole reversals. There once was a geologist who got so excited about analyzing lava samples, well, you probably don't want to know the details. Let's just say his obsession with rocks went a little too far. But I digress. By understanding the patterns and timing of pole reversals in the past, scientists can make educated predictions about when we may be due for another one in the future. Some researchers think the next flip may already be starting, given how quickly the poles have been drifting in recent decades. Of course, precisely pinpointing the next reversal is impossible with current models. There are too many variables in the complex dynamo dynamics of the outer core. However, continued research will help refine estimates and give more lead time to prepare for potential disruptions. The more we understand about the reversal process and its geological record, the better we can anticipate this bizarre phenomenon and its effects. Who knows, maybe one day we'll even find a way to predict pole reversals decades or centuries in advance. Now that would throw your compass for a loop. Let me know your thoughts on magnetic pole reversals in the comments below. Are you excited by the prospect, or does it make you a bit nervous? And hey, if you want to stay up to date with more mind-bending science like this, don't forget to hit that like button, subscribe to the channel, and ring that notification bell. Thanks for watching, and remember, in a world of shifting poles, sometimes the only constant is change itself.